All right, cross-connection control. Bessie talked a little bit about cross connections earlier, but let's refresh. What's cross connection? Y'all both got it. Potable connected to anything non-potable or unknown source. It may be potable, but if you don't know where it came from, it's a cross connection. What are some examples of cross connections? Pineville. You know, and sometimes it's not even something as significant as that. You might have a residence, they don't have a backflow preventer on their water hose. I understand y'all have a ordinance or regulation that all homes must have them, but realistically, who goes out and enforces it, right? With the best intentions, we may try to, but you know, you could go out and check the resident, and as soon as you leave, well, that takes away water pressure when I'm trying to wash my car, so I'm gonna unscrew it. Well, they might have that hose laying in the backyard. They've got a low lying spot in the backyard. Pressure drops in the system, they could suck something back in there. We did have a back T sample location where we kept getting positives at this one location. Couldn't figure out what was going on. Upstream, downstreams were coming back good. Started checking things out. Somebody said, we walk around the back of the house. Sure enough, they had a water hose laying in stagnant water. Well, they were in an area that had fairly low pressure. Well, just them turning on that tap in the front was enough to create a siphon in there, was sucking stuff out of that water hose back into the house. We had another case, more recent than that. We started getting customer complaints of blue water. And I'm not talking like pretty blue water like, you know, you see at the ocean, you know. I'm talking as blue as his hat back there. I mean, we were stumped. We couldn't figure out, how could this water be blue? I mean, I've seen red water, seen brown water, you know, seen it, you know, all kinds of colors, but blue water, you know, we were stumped. Nobody could figure out. We looked in books, we talked to different people trying to figure out what would cause blue water. Is there some kind of a weird bacteria out there? There actually is a bacteria that will turn your water pink, not red, but like a hot pink. Seen it once. But this blue, we're trying to figure out, well, where could this be coming from? What's going on? Got out there, started checking our system, and we noticed it was just isolated to this one, you know, fairly small area. We started checking hydrants, tracking it back, traced it back to this warehouse building. Made contact with the occupants. Turns out they were making some sort of a dye in there. Some sort of a little manufacturing setup inside there. They were making blue dye. Well, they had a direct connection to their dye tank that was bottom filled. They didn't have an air gap. Well, some of that stuff was getting sucked back into the system. All it takes is a little bit of it. Looked like we had blue toilet water going out in the system. You know, fortunately, it was a food grade dye. It was something that wasn't harmful, but it sure scared a lot of people. It had people upset where they didn't want to drink the water. It could be both. Now, the way our ordinance in Houston works, if you're a high-risk customer, if you've been identified as having some sort of a risk, you have to have a backflow preventer on your facility. But like normal residents, we haven't got to that point. We are working on it. They do want to change the ordinance to require it, but they have not gotten to that point yet. Yes, they are going to work. They're working towards.
You know, it looks like the meter would be built as a one-way valve, and then they wouldn't have to worry about it.
Cost.
Just a check valve.
On the faucets. Yeah. Yeah. Well, like I said, around Houston, there's a lot of smaller cities. I used to have I used to have a little storage shop in a city called Pasadena that was right next to us. We had to get an occupancy permit. They came in, that was one of the things they did. They came in and said, you need to have some sort of a backflow preventer on all your hose bibs and everything. So, you know, they're working towards it. We just haven't got to it yet. What'll probably end up happening, the state will come in and make it a state requirement, then we'll be forced to act. Yes. Yep. Well, like I said, ignore the TCEQ requirements, but the recommended practices, which are regulations for most states, you want to have some sort of an air gap. Air gap is the most effective method of cross connection. Basically what an air gap is having a physical separation between the two sources. The standard is 2 times the diameter of the pipe, and here in Louisiana, the minimum, regardless of size of pipe, is 2 inches, but it's recommended 2 times the diameter of the pipe. You can have backflow prevention device like you talked about, a double check. There's also RPZs, reduced pressure zones. You know, you want to have those, particularly if you don't have an ordinance that requires them for all customers. You want to try to at least identify your high-risk customers. You know, people who are dealing with materials that are likely to cause a problem if they get back in the system. Yes, sir.
They made it mandatory, I think, because of all commercial buildings now they have fire sprinkler systems.
Uh-huh.
Have stagnant water that's inside in line, out in the building for a period of time.
Yes, we are seeing that too.
Without flushing.
Yeah.
They have a sprinkler system. Yeah.
Okay, so even if you have any type of a sprinkler system, you require one. That's a very good practice.
Even if it's coming off your water, off your water bill outside,
Uh-huh.
you must have that check.
Okay, so like if you have a yard sprinkler, you have to have one too.
Yard sprinklers, you know, some of them go out and put it off in their yard, and they do it themselves, and they tie it to the water.
Yeah.
Well, they can't tie it directly to the water hose now. They must go put that check right between them.
Okay. Now, do y'all have somebody who enforces that?
Not really, it's just,
Kind of an honor system?
you go out there on a job, and say, if I go out on a job, and I'm finna do something, and I happen to see it, I bring it to their attention.
That's a good thing to do. One thing you do is educate your customers. Let them know why you're requiring this stuff. Because a lot of times if they realize it could impact their health, it could make them sick, they might voluntarily comply with the stuff. Like we talked a little bit earlier, we all know that we all have emergencies in our system. Well, what happens when you have that emergency? Usually you're scrambling around trying to figure out what happened. Who knows how to fix this piece of equipment? One thing you can do to help eliminate some of those problems, in advance, locate all your repair manuals, know where they're at. You know, don't rely on the maintenance guy who's been there for 30 years that knows how to fix everything. Because what's going to happen if he's not there the day it breaks? Everything's going to break the day after he retires. Have those manuals on hand in advance. Have some spare parts. I know we can't have every spare part possible out there. You know, especially if you got a system and you got 5 different brands of pump, you can't have a spare set of bearings for every one. You can't have a spare packing gland for each one. Find out which ones are the hardest to replace, maybe the ones that are discontinued, hard to find. You know, find out the ones that have long lead times, the ones that are most likely to break. Try to have some of those parts on hand. That way when something breaks, it doesn't turn into a disaster, doesn't turn into an emergency where everybody's running around trying to figure out what do we do. Now when you have a more severe emergency, something more severe than just a broken down piece of equipment, say you got a hurricane coming. You know, I would say a tornado coming, but you don't necessarily know when a tornado is coming. You know, have some sort of a plan for any disaster that might happen. You know, have your personnel, you know, alert them, make sure they know what's going on. Have a plan in place. Don't wait until the day that the hurricane's going to hit to decide who's working. You know, have some sort of a written procedure in place. That way, whatever happens, people know what to do. It should become second nature for them. Don't write it and stick it on a shelf and never look at it again. You know, practice it once or twice a year. Go over it. When you have major changes, you have personnel changes, make sure the new people are up to speed on it, know what to do. If it's something like that could potentially be a long-term thing, like a hurricane where you might have a major power outage, you know, I don't know, do y'all get snowstorms up here? Are we far enough north to get snow? Okay. We don't get, if we get an inch of snow in Houston, we freak out and shut everything down. Y'all get quite a bit of snow up here? Just ice? Okay. But yeah, if you get some ice, anything like that, something that you think could cause a potential problem, go ahead and top off all your tanks. You know, maybe isolate a tank to where you can use it for reserve only if you need it for that emergency. You know, don't just leave it isolated year round, because then you're gonna have bad water in it. But you know something's coming, go ahead and isolate that tank so if the line right out in front of it breaks, you know, you'll still have that full tank so once you get the repair done. As you're doing the repairs, you know, make sure you restock all your materials. Don't wait until the next disaster to restock those materials that you used during that disaster. You know, because that's, you know, a lot of times we're good about, all right, we get gung-ho, we're gonna make this repair, we're gonna make this plan, we're gonna stock all these parts. Well, then that pump breaks, we put that spare part on. Do we go back and replace it immediately, or do we wait until the next time it breaks to try and get it again? You know, try to be proactive on this stuff. I'm sure everybody here has seen one of those before. If you haven't, you probably haven't been in this business very long. That's your standard booster pump right there. Most of our booster pumps are centrifugal. You know, they're not a one-size-fit-all application. You can't just grab any pump off the shelf and say, hey, I've got this pump available, I'm gonna use it. I don't care what it's designed for, I'm gonna use it. Here's a cutaway of that centrifugal pump. So we know that a motor spins that pump. You know, the pump and motor, we generally refer to it as one unit, we just call it the pump, but it's actually two separate components. The way it works is that impeller spins. Impeller, everybody knows what the impeller is, correct? Anybody not know what an impeller is? Gotta ask. Well, as that impeller spins, it creates a centrifugal force. It's the same principle as if you take a bucket of water and you swing it over your head, where does that water go? Pushes out to the sides, right? So it doesn't dump out. Well, it works on the same principle. As that impeller spins, it creates a centrifugal force inside that housing. And it spins that water towards the opening and shoots it on down your line. Now, you've got your deep well turbines. That's your general groundwater well. Now, the difference there is, instead of having one big pump, it's a series of small pumps that lift it in stages. It starts out at that lowest level, pushes it up a certain distance. At that level, there's another pump, and it just keeps pushing it all the way up to the top. Benefit of that is you don't have this one giant massive pump sitting underground trying to push all that water up. It's a lot more efficient by doing it this way. Now they can be oil or water cooled. This is an area that sometimes people forget to check. They forget because it's all underground. They don't think about checking and making sure there's oil. I know most of ours are are oil cooled. They actually have a dripper that drips about 1 drip a second down the shaft to lubricate it. We use a food grade white oil. You know, one time we accidentally got some colored food grade oil. That got out into the system and we started getting complaints. So we make sure now that we get a clear oil. Now, when you're picking out your pump, you got to consider a lot of different factors. The amount of water is going to be pumped. What kind of head are you pumping against? The head is any pressure that's pushing back against that water trying to be pushed out. What kind of material you're going to be pumping? Like I said, when we talk about pumps, we generally think of what? Water pumps, right? But there's a lot of different kinds of pumps in our facilities. You might have a chemical transfer pump, a fuel pump, fuel transfer pump, oil pumps. You know, so pumps are not one size fit all. They're built to pump different materials. Like at one point we were pumping like a commercial bleach. We were using it to disinfect our new lines. Well, we had to go out and buy special pumps that were made all plastic and stainless steel. That way they could handle that bleach and hold up to it. Now, could we have bought just a regular pump off the shelf and pumped it? Would have worked for a day or two, but it would have quickly been destroyed. So make sure you know what kind of material you're planning on pumping. And it's not just a matter of if it's a chemical or not, but if you have a very sandy water, you have a lot of grit in your water that you're pumping, you got to take that into consideration because all that grit can destroy that impeller if you don't get the right one. You know, we all know that the people who make the financial decisions, all they want to look at is, well, what's the cheapest one? While that's an important factor, try to educate them so that's not the only factor in deciding what pump you get. I know that's a lot easier said than done. It's usually a matter of, well, it's low bid, we have to take it. Try to educate them why you need a particular piece of equipment. You have to take into consideration the availability. While you may have the ideal pump picked out, if it's not available for 6 months and you got a pump that's down today, you might have to make a second choice. So take into consideration, you know, how soon you'll be able to get it. Is it timely? Is it available at all? What is the pump efficiency? You know, how much do you need to pump? The pumping rates, they're usually rated in either gallons per minute or 1,000,000 gallons a day. If you're looking at a 1,000,000 gallon a day pump, that's usually a pretty good sized pump. Most stuff you're looking at will be rated in the gallons per minute. Like I said, the head is the force that your pump is trying to work against. Now you'll hear static flow or static pump, static head, and dynamic head. The static flow is the measure of the center line of the pump to the free discharge. If you hear static head, that is whenever the pump's not running. A dynamic head, that's the pressure that it's going against while the pump is running. Now, we already talked about the static lift, that's the distance that the source of water or whatever's being pumped is below the center line of the pump. A suction head is when that water source is below your pump. Now, the discharge head is how high that water you're trying to pump it above that pump. The total static head, that's the difference between the previous two, the suction head and the discharge head. Friction head, you know, a lot of times we forget about, you know, them pipes aren't completely smooth. You've got a lot of turns, you got bends, you got different roughnesses of the pipe. Well, that's where you get your friction head. That's the resistance caused by the pipe itself. And the total dynamic head is the combination of the static head and the friction head. Now this is something, unless you're the engineer, you may not be asked to look at too often, but depending on your system, a lot of times I know in smaller systems you have to do everything, so you may be asked to look at the pump curve. This is a very useful tool in determining will the pump you're looking at meet your needs. You've got the different lines there. It'll show you what the head, you get the gallons per minute, the horsepower. If you can get two of the factors you've got, you know what size motor you've got, you know what kind of head you're pumping against, or you know what kind of head you're pumping against, and you know how many GPMs you need. If you can get two of the factors, you can use one of these pump curves and figure out what size pump you need to buy. Now your pump efficiency, this is what it sounds like. How efficiently is your pump running? Check it periodically. The purpose of checking it periodically is if you check it regularly, you see that you start seeing a drop in your deficiency, you can catch a problem before it becomes too big of a problem. You know, it's just like that's why we get yearly checkups, right? We all go to the doctor once a year, dentist twice a year. At least we should. As your head increases, remember, the head is a force you're working against. So as you get more head, your efficiency it reduces because you're trying to fight against more friction, more force pushing back against you. So your pump's going to become less efficient. Also, if you have a high suction lift, that's going to reduce your efficiency. A worn or clogged impeller. Remember, that impeller takes that water, spins it around, creates that centrifugal force pushing it out the side. Well, as that impeller wears, it's going to become less efficient. If you have a impeller or a pump that was built in the past about 3 years, you probably need to check those impellers a lot more frequently than you used to. Because when they changed the lead and copper rule, they changed the amount of lead they were allowed to put into the alloys that they make the impellers out of. I've got a brand new plant, came online about 3 years ago. Within a year of the plant being in service, we had to replace all the impellers. The manufacturers went to this much softer material that had less lead in it. Found out it doesn't hold up. Within a year, all four of the pumps at this particular plant, impellers were garbage. Looked like we had been pumping gravel through them. That I couldn't tell you. Our maintenance guys handled the replacement. When I find a problem, I call them to come out and fix it. Again, to help maintain your pumps, keep your pump room clean. It's the same thing we talked earlier about the housekeeping. You know, it creates a safer atmosphere. It looks better. You know, it makes your employers happier. You know, who wants to go and work in a dirty, filthy pump room every day? You know, sweep it out. Keep debris out of there. Keep stuff not stacked around your equipment. Any pumps you have, it's ideal, while it may not be a requirement, it's ideal if you put a isolation valve on each side of that pump. So if at any point you need to pull that pump out for service, you need to take it out for maintenance, you know, you have a way to isolate it. You're not having to isolate your whole distribution header or your whole plant even. We talked a little bit earlier about make sure you got that check valve on your pump. That way you don't have any pressure from your system coming back in, because water is going to seek its, you know, the lowest point. You know, it's going to look for where the pressure is the lowest. Your plant's off, you got 50 psi in your system from another plant. What's it going to do? It's going to push right back into your plant if you don't have some sort of a check valve there. Some problems you might encounter on your pumps: misalignment of pumps and motors. Remember, like I said, we think of them as a single unit, but it's actually two separate pieces of equipment working together. Well, generally they're sitting on some sort of a foundation, whether it's, you know, a steel base, a concrete pad, whatever it is. Well, over time, that stuff can vibrate, it can move, it can get loose. Next thing you know, one's sitting slightly higher than the other one, one's sitting a little bit a different angle than the other one. Well, that's going to cause you problems. It's going to wear out your couplings, it can damage your shaft, it can reduce your efficiency. So periodically, maybe once a year, go out there, square up that coupling, make sure everything's aligned like it should be. Get foreign materials in your impeller: sand, you know, chips of paint, you know, anything that could get sucked in there. Most common one is sand. If you have a sandy, you have a well, gets maybe a bad screen on it, start pumping sand into your tank. Next thing you know, you're pumping sand through your booster pumps. That can create major problems for that impeller. Or if you get an air leak at your suction, you know, the centrifugal pumps count on there being a positive pressure at all times. Well, you start sucking air in there. Now instead of spinning that water through, you're spinning air around in there. Now you've got an airlock pump. What would cause a pump to rotate backwards? Bad check valve? Any other ideas? I heard something about wiring back there. Yes. This is one, if you just have a new motor put in, you maybe have some sort of maintenance done, you suddenly see it spinning backwards, have your electrician check and make sure they didn't wire it backwards. Sounds common sense, but I've seen motors wired up backwards and you're like, something just doesn't seem right. Keyword supposed to, right? Because we know everybody does everything they're supposed to, right? Cavitation, that's a big one. Who can tell me what cavitation is? Got air, replacing volume. Say it a little bit louder so everybody can hear you. Yes. Little tiny air bubbles, they get in your line. They get inside your pump. As that impeller's spinning, it's popping all these little air bubbles. There are thousands or millions of little tiny explosions against that impeller. They slowly chip away at that impeller. You can destroy a pump really quick with that. It'll sound like you've got rocks or something in there. Yes, I didn't think about that, but true. Also, you got water hammer. We all know what water hammer is. It's just like we talked earlier. You got that water flying through there 5 feet a second. All of a sudden, you drop a valve in front of it. Well, that water doesn't have brakes. It's going to hit whatever is in the way. You can blow a pump off the base. You can blow a line out of the ground. You can blow things apart. You major damage. The biggest thing to prevent that, anytime you're going to introduce something that's going to stop the flow of that water, do it gradually. It's not a competition to see who can spin the valve fastest. I've seen guys who think it is. I have to tell them, this is one time that you have to tell city employees, slow down. Any other time, it's like, come on, can you move any faster than that? Like I said, this is all pretty much the same thing as your pumps, as your storage tanks. You want to protect them from contamination, keep them out of contaminated areas. If you do have a vacuum leak, address it, immediately, because that's a quick way. Remember, that water is being sucked into that pump. If you have any kind of a leak on the suction side, it's going to suck in whatever's around it. Whenever possible, maintain a positive suction head. That'll keep that pump flooded. It'll keep an outward pressure on it. We're almost done with this section. We got one short section after this. Electric motors. The most common type is the squirrel cage motor, or I don't know why they call it that. Anybody know why they call it a squirrel cage induction motor? Does it look like a squirrel cage? I didn't think about that. But I wonder why they didn't call it a hamster cage then. Probably whoever came up with the term had a pet squirrel, right? This is what I preach to my guys all the time. Whatever you have, when in doubt, follow the manufacturer's recommendation. What does that do? If something screws up, it's not your fault. You did what the manufacturer said. Because you better believe if you do something different and it breaks, that manufacturer's going to point the finger back at you. Jim broke it. I didn't. Hey, if he had followed what I told him, regardless if they knew there was a manufacturer defect, they knew it was poor workmanship on their part, if you didn't follow their recommendation, they're going to say, you broke it. It's not my fault. Now that $50,000 motor you just bought that burned up because you didn't use the oil they recommended, even though you put a comparable oil in, you didn't follow their recommendation. They're going to point the finger back at you and say, not our fault. People don't think about these motors get really hot. You have high voltage running through them, spinning, a lot of friction. They generate a lot of heat. Make sure you have ventilation around them. Don't use your pump room as a storage where you can stack stuff around it, where you got no airflow getting to that motor. Also, make sure you have some sort of airflow into your building. Some people might say, well, I want to seal my building off so nothing gets